Chapter 1 Electric Charges and Fields. We all might have an experience of getting a mild shock when you touch a metallic knob or a handle after walking through a carpet. Perhaps when you comb your hair on a dry winter day, you had an experience that your hair stick to the comb. Or maybe you have made a balloon stick on the walls after rubbing it against your cloth. Why do these things happen? Is this a magic? No. Have you ever tried to find any explanation for this phenomena? Yes, this is because of static electricity. So this is the topic that we are going to discuss in this chapter. Static means anything that does not change with time. So static electricity means stationary electric charge. The branch of physics which deals with charges at rest is what we call electrostatics. Now, our question is, how do we produce static electricity? How does a neutral object become charged? And what effect does that charge have upon other objects in its vicinity? To answer these questions, let's see some experiments. When you rub two glass rods with a silk and brought these glass rods close to each other, they will repel each other. Similarly, when two plastic rods rubbed with cat's fur and brought close to each other, they will repel each other. But if the glass rod which is rubbed with silk and plastic rod which is rubbed with cat's fur are brought closer, they attract each other. Now, if you suspend two pit balls by a nylon thread or a silk and a glass rod which is rubbed with a wool or a silk is made to touch these two balls. Now what happened here is they repel each other. A similar effect can be seen if you touch these two pit balls with a plastic rod rubbed with cat's fur. They repel each other. But an exciting observation is that when you touch one pit ball with a glass rod and another pit ball with a plastic rod, then these two pit balls attract each other. So, from the previous experiments, we can conclude that when two materials rub each other, they accuse an electric charge, or we can say that they are electrified. Also, there are two kinds of electrification. Like charges repel each other and unlike charges attract each other. In this pit ball and glass rod experiment, this pit ball was a neutral object. When a glass rod, which is rubbed with a silk, was made to touch with this pit ball, some of the charges from this glass rod are transferred to the pit ball and the pit ball are electrified. From this we can conclude that an uncharged body can be charged by contacting with a charged body. So this is our fourth conclusion. The property which differentiates two kinds of charges is what we call polarity of charges. In this experiment, when glass rod is rubbed with silk, glass rod accuses one type of charge and silk cloth accuses another type of charge. We don't know what kind of charge are they. When they touch each other, their charges cancel and they became a neutral object. They lose their charges when they are brought in contact. So this means that unlike charges acquired by the object, neutralize each other's effect. It was a famous American scientist, Benjamin Franklin, who named the charges as positive and negative. Because in mathematics, if you add a positive number with a negative number with the same magnitude, their sum will be 0. The same effect is what you have seen in the previous experiment. When a glass rod is rubbed with silk cloth, glass acquires a positive charge and silk cloth acquires a negative charge. Suppose the glass rod acquired +3 charge and silk acquired -3 charge. When they brought in contact, their charges cancelled each other, or total charge on both the objects are 0. So this might have been the reason why Franklin named the charges as positive and negative. So there are two types of charges, positive and negative. If an object acquires some charge, then it is said to be charged or electrified. If it has no charge, then it is said to be a neutral object. Now, why material bodies accuse charge? We know all matter is made up of atoms. and inside an atom there are protons, neutrons and electrons. Of these three particles, only proton and electrons are charged, where proton is positively charged and electron is negatively charged. Neutron is a chargeless particle. Generally, the atom has a neutral charge, but if it loses an electron, it becomes positively charged, and if it gains an electron, it becomes negatively charged. Charged atoms are what we call ions. Therefore, all things are made up of charges. Most of the time, these positive and negative charges are balanced in an object, which makes that object neutral. Now, how can we charge a neutral body? When two objects rub each other, the electrons, being less tightly bound in an atom, are transferred from one object to other. When this happens, one material then contains excess of electrons and becomes negatively charged, while the other one contains deficiency of electrons and becomes positively charged. You can see there is no new charges are created in the process of rubbing. Only transfer of charges takes place. Moreover, the number of electrons that are transferred is a very small fraction compared to the total number of electrons in the material body. Because in a material, there are millions of atoms and electrons. Of these, only few electrons, which is loosely bound in the atom, are transferred from one object to another by rubbing. Now, have you ever thought why would there be a transfer of electrons? We know different materials are made up of different types of atoms. So, the presence of different atoms in object provides different electrical properties to material objects. One such property is known as electron affinity, which means some materials have a great affinity to take electrons from another material. So, this is called electron affinity. Different materials have different affinities for electrons. When you rub two materials, do you know which one get positive and which one get negative? To understand that, materials are ranked in order to their ability to hold or give up electrons. This ranking is what we call Triboelectric Series. This is a Triboelectric Series. A list of some common materials is shown here. Materials at the top of the series are more likely to give up electrons while rubbing and become positive charge, and materials at the bottom are more likely to gain electrons and becomes negative charge. In the middle, there are some materials like paper, cotton, steel and wood that do not show strong tendency to behave either way. That is why we have to stick to certain pairs of materials to notice charging by rubbing two materials. Now, take a pair of material, for example, glass and silk. Here, silk is lower in the list compared to glass. Hence, it have a greater affinity for electrons than glass, so it pulls electrons from the glass rod and silk becomes negatively charged, and glass rod give up electrons and becomes positively charged. Now, take another example, human hair and rubber. Rub a balloon on your hair. We know balloon is a rubber, so it have a greater affinity for electrons compared to hair. So while rubbing, electrons are transferred from hair to balloon, and hair acquires a positive charge and balloon acquires a negative charge. So if we consider a pair of materials and if they are farther away from each other on the series, then greater the charge transfer. Materials near to each other on the series may not exchange any charge. So, to notice charging by rubbing two materials, you have to stick to certain pairs of materials. So, this idea you will get from a Triboelectric series. Today, we have discussed about static electricity. How do we produce static electricity? How does a neutral object become charged? Why charges are transferred while rubbing? And we have also discussed about Triboelectric series, which is used to check which object becomes positive and which one becomes negative after rubbing. In the next lecture, we will discuss how to detect the charge on a body using electroscope.